All right, 10-2, one of those random end of the year lessons right before the EOI. Um, Here we go, simplifying radical expressions. Okay. Truthfully, a lot of this is calculator work if you have the right calculator. Um, if you don't have the right calculator, I'm going to show you how to do it by hand. All the writing's there already, so try and follow along best you can. Let's jump into it. Okay. First principle, any number under a radical is technically two numbers multiplied together, right? So if you can split up those two numbers, then we can simplify a little bit better, okay? So for example, square root of 54 is just square root of 9 times 6. Okay, we can split this up to square root of 9 times square root of 6. Square root of 9 is 3. Square root of 6 doesn't give us a nice even number, so we just leave it as square root of 6. So that's the simplified form. If you put this in the calculator and hit enter, it would spit this out. Okay, so it would do that on all numbers. Now, if it has it separate, like, and you'll see this black box, that's what's given. I went back and added those to let you know kind of where we start. This could also be plugged in the calculator, hit enter, but this is what's going on. 14 times 2 would be square root of 28, which is 2 times 2 times 7. And this is kind of how square root works. Anytime you're underneath this radical, if you have a pair of something, those come out to be one of whatever this is. So if you have a pair of tens, they come out to 110. If you have a pair of variables, they're going to come out to one variable. Okay, so 2 times 2 times 7. The pair of 2's come out, the radical 7 stays underneath. So this simplified is 2 square root of 7. Now, working with variables. X squared, square root of x squared. If you know anything about squared and square roots, they kind of cancel each other out. So does x always equal square root of x squared? Not necessarily the case. Let me go back here for a little bit. Okay. Technically, each of these numbers that can be perfect squares, they're technically plus or minus 3. However, for all of your stuff today, we're going to assume that we're using the positive number. Okay, which kind of brings me to this. Okay, what if x was supposed to be a negative number? Negative squared gets you positive 9, and this gets us to our plus or minus 3. Well, the positive 3 doesn't match negative 3, but the negative 3 does. But assuming that it's like that, we have to work with our variables a little bit different. Okay, any odd exponents on the outside of the radicals needs an absolute value sign. With the numbers having an exponent of 1, they technically don't. They want you to assume that they're always going to be positive. Variables, on the other hand, different story. So we're going to start with this stuff here in red. Square root of 90, x to the third, y to the fourth, z to the fifth. Okay, here's a little trick. You cannot put this whole thing in the calculator because it has variables. Do not put variables in the calculator. Do not put variables in the calculator. Do not put variables in the calculator. However, this part right here, square root of 90, we can put in the calculator. And when you put it in the calculator, you get 3 square root of 10 because that's 9 times 10. 9 is 3 times 3. Okay, so that 3 is going to go here. That square root of 10 is going to start inside of our radical. Now, if you remember, we're looking for pairs. I have 3 here, so I only have one pair with 1 left over. So my x will be 1. My leftover goes inside there. With my y's, I have 2 pairs. Pair there, pair there. With z's, I got 2 pairs with 1 left over. So z squared and z left over. Now, these purple lines here, these are the absolute value sign. This kind of makes it to where they know that this could be plus or minus x without having to write plus or minus. Okay, so when you have a variable with an odd exponent, just throw the absolute value signs. Okay, so it's going to look something like this. X squared becomes x to the first power, so you throw your absolute value. X to the third, we have 3 of them, so 2 become 1 pair, 1 left over. That's still odd, throw your absolute value. This becomes x squared. Even number, don't worry about it. skipped 5 because 5 is going to be square root of 2, or sorry, x squared with the square root of x. But x to the 6 becomes, there's 3 pairs. That's an odd, so use your absolute value, because that'll take care of any negatives or positives that may kind of go that way. Okay. Now, square root of a fraction. Okay. Can't have any radicals in the denominator, so we can't technically have that. Hopefully, when we're working with this, it'll make a nice even number. We can have numbers in the denominator, but not any square root signs. Okay. If we do, I'll show you how to get rid of them. But what we want to do in the calculator is, instead of putting it like this, let's split it up, square root of a over square root of b. Put it in the calculator more like this. This will generally give you a decimal. This will generally give you the simplified form. So, square root of 56 over 45. Put it in the calculator. It's like 1 point something. I don't even know. Figure it out later. Okay? But what we want to do is we want to put it in the calculator more this way. Okay? Square root of 56 over square root of 45. Hit enter and it will give you your answer. Okay? Let's work it out by hand. 56 is 7 times 8, so 7 times 2 times 2 times 2. 45 is 9 times 5, so 3 times 3 times 5. I have a pair of 2's, go here, and 2 and 7, they don't have anything left, so that 14 stays. Got a pair of 3's, that goes here. 5 stays there. Now I cannot have this, okay, so if you look down here, I'm going to take this radical, I'm going to multiply by 1. Notice 1 is written not quite as the number 1, but anything divided by itself is 1. So square root of 5 over square root of 5. Okay, so now I have this 2 times 7 times 5 to give me 70 with the 2 still outside. This 5 and this 5 becomes square root of 25, and the square root of 25 is 5. So 5 times 3 gives you the 15, so that's where that comes from. So to get rid of these, just use that radical. Okay, with variables, it's a little bit different. Separate top and bottom. Okay, and we can kind of put this in the calculator, but you got to be really careful with these variables. I suggest doing it by hand, that way you don't miss anything, but it's possible. Now, square root of 6 over square root of 12. If you put it in the calculator, it'll give you square root of 2 over 2, which is close, but remember we have this y that's on top underneath the radical, so we're going to put it on top underneath the radical. It didn't have anything else to combine with. Okay, something like this, where we have a denominator, we still split it up, but we can't really put that in the calculator. So there's an understood 1 right here, so let's use that 1 and get radical 24 and hit enter. Let it simplify this to square root of 6 over 12. Then you look, okay, my x is under the radical, so I'm going to put the x under the radical. Just adding those variables right back is probably the easiest way to do it. Lastly, 3 over 5 plus square root of 2. We cannot have that radical at the bottom. Okay. On the other ones, we'd go, oh, square root of 2 over square root of 2 multiply. Can't quite do it because of this lovely plus sign here. So we are going to use, we're going to use what's called a conjugate. And a conjugate is basically the opposite sign of whatever this is here. So instead of 5 plus root 2, we're going to do 5 minus root 2. And to make it 1, 5 minus root 2 over 5 minus root 2. Okay. With these, we're basically going to FOIL them as if they were variables or anything like that. 5 times 5, let's just put at 5 squared. 5 times negative root 2 and 5 times positive root 2, those will end up canceling each other out. And then root 2 times negative root 2. Okay, looks like this. So if you remember, this is difference of squares stuff, chapter 8, lesson 5, I believe. Okay, x plus 2 and x minus 2. The x times x became x squared, and the 2 times 2 became 2 squared. Well, it's the same thing, 5 squared and radical 2 squared with my subtraction sign in between. Well, the radical and the squared kind of cancel each other out, so that becomes 2. 5 squared is 25. 25 minus 2 gives you 23. Oh, by the way, you can put this in the calculator, it'll spit it out. So that gives me my denominator, because that's what we were working with. So on top, all you got to do is basically a little bit distributing. The calculator generally puts out the radical first, but if you did 15 minus 3 radical 2, it'll work. But 3 times 5 gives you this 15. 3 times negative root 2 gives you negative 3 root 2. Okay, but that's all calculator work. Most of this can be put in the calculator. Okay, but you got to be careful with the variables. If there's no variables, just make sure you enter it in right. Hit enter, and you'll be fine. But that's how you do it by hand. All you got to do is kind of break it down and start pulling out pairs. Okay, so that was 10-2, simplifying radical expressions. 10-3 is tomorrow, or the next video, I suppose. It's mostly calculator work. I'm going to show you a little bit about how it's kind of what's going on behind the scenes, but it's pretty much all calculator work, so it'll be a nice easy day for us.